Hey students, I hope you're all having a great day today. My name is Torres and I want to take a moment to thank you for joining me for a little Psych 101. In this video, we will learn about developmental psychology with an emphasis on the role of cognition in developmental psychology. This is the second part of a three-part video series on developmental psychology. This video has three overarching ideas. Lifespan development explores how humans change, grow, and remain the same from conception to death. Human development can be studied scientifically across three domains: physical development, cognitive development, and psychosocial development. Different theories focus on the processes, patterns, generalizability, biological influences, and environmental influences on human development. The topic of this three-part video series on developmental psychology will focus on the vocabulary on these three slides. You can find this information in the Google slide presentation and in the Psych 101 Key Vocab Google Doc. Both of these files are linked in the description box below.
Developmental psychologists study how students change and grow throughout their entire life, from conception through childhood, adolescence, adulthood, and death. They view development as a lifelong process that can be studied scientifically across three developmental domains: physical, cognitive, and psychosocial development. Physical or biological development involves growth and changes in the body, brain, senses, motor skills, and health and wellness. Cognitive development involves learning, attention, memory, language, thinking, reasoning, and creativity. Psychosocial development involves emotions, personality, and social relationships. There is much debate on what could be considered normal development. Normative psychologists have studied large numbers of children to determine norms, or average ages, of when children reach specific developmental milestones, like crawling, walking, speaking in sentences, and starting puberty. Biological milestones, such as starting puberty, are universal. Social milestones, such as starting school, can vary considerably across cultures. Developmental psychologists have come to different conclusions concerning how exactly humans develop biologically, cognitively, and psychosocially. Some psychologists believe that children develop smoothly and continuously, but other psychologists believe that children develop more discreetly in a series of stages, each of which is fairly stable. Developmental psychologists who believe children develop continuously believe that kids constantly add new lessons and skills on top of old lessons and skills as they get older. They believe that children grow at a steady, uniform speed. Even though parents can't see it with their eyes, children are growing all the time in front of them. Their bodies are making new cells, their minds learn new skills as they play and interact with people every day. On the other hand, developmental psychologists who believe children grow discontinuously believe children grow in stages as they seem to develop chunks of abilities and to experience events at certain times in life. To some parents, it may seem that their children learn to do things all of a sudden, like when a baby goes from only being able to crawl to being able to toddle around on 2 feet almost overnight. To kindergarten and first grade teachers, it seems as though their students just learned a few sight words, and now all of a sudden they can read a whole book by themselves. In these examples, it seems that these children are making physical and cognitive gains in spurts at special times, and then are not making any gains as quickly for a while in between the spurts. Another question of interest in developmental psychology is whether or not development is universal for everyone. In other words, is development essentially the same or universal for all children? Is there only one course of development, or does development follow a different course for each child depending on the child's specific genetics and environment? Are there many courses of development? Do people across the world share more similarities or more differences in their development? And how much does culture and genetics influence a child's behavior. Stage theories hold that the sequence of development is universal. For example, in cross-cultural studies of language development, children from around the world reach language milestones in a similar sequence. Infants in all cultures coo before they can babble. They begin babbling at about the same age and utter their first word around 12 months old. Yet we live in diverse contexts that have a unique effect on each of us. For example, researchers once believed that motor development follows one course for all children, regardless of culture. However, more recent research indicates that childcare practices can have a significant effect on various motor skills, such as sitting, crawling, and walking. Depending on the childcare practices of a culture, this can either accelerate or inhibit achievement in the developmental milestones associated with these physical tasks. The nature versus nurture debate is concerned with the extent to which particular aspects of behavior are either inherited or genetic, and which ones are acquired or learned. In this debate, nature is influenced by genetic inheritance and other biological factors, where nurture is generally taken as the influence of external factors after conception. So it is the product of exposure, life experiences, and learning. The general consensus is that both nature and nurture are important in development, but psychologists debate the contributions of each.
Cognitive development focuses on how humans acquire, organize, and learn to use knowledge. The focus of cognitive development has often been only in childhood. However, cognitive development continues through adolescence and adulthood. It involves acquiring language and knowledge, thinking, memory, decision-making, problem-solving, and exploration. As I mentioned, much of the research within cognitive development in children focuses on thinking, developing knowledge, exploring, and solving problems. The Centers for Disease Control and Prevention, or CDC, has published lists of developmental milestones for young children. Developmental milestones are lists of accomplishments that infants, toddlers, and preschoolers generally achieve by a certain age. Children develop at different times, but if a child is consistently missing milestones, it might be necessary to further evaluate. Cognitive milestones represent important steps forward in a child's development. Throughout human history, babies were often thought of as simple passive beings. Actually, babies have remarkable intellectual skills. Babies are, in fact, always learning, thinking, and exploring the world around them. Even newborn infants are actively taking in information and learning new things. In addition to gathering new information about the people and world around them, babies are also constantly discovering new things about themselves. The first 3 or 4 months of a child's life are a time of wonder. Major developmental milestones at this age are centered on exploring using their basic senses and learning more about their body and environment. Around 2 months old, babies will start to recognize familiar faces from a distance. At about 4 months old, a child will begin to reach for an item with one hand. And at about 6 to 8 months old, they'll be able to start to shake their head no when they're not in favor of something. During these first few months of life, babies inhabit a world of here and now. While they recognize some familiar faces, their memory development is in its earliest stages and they explore the world through movement and senses. This time, it appears as though babies cannot form and retain a mental representation of an object. They can only understand the world that consists of things that they can immediately see, hear, and touch. At about 8 months old, a baby will acquire object permanence. Object permanence means a child understands that things and people still exist, even when they cannot be seen or heard. Object permanence can be tested by gauging a child's reaction when their favorite toy is hidden. If the child appears confused or upset and does not look for the toy, then they haven't yet grasped the concept of object permanence. If, however, they start looking for the toy, then they know that it still exists and they want it back. Consider the favorite game, Peekaboo. In Peekaboo, a parent might hide their face and then present their face to the child. Peekaboo is a natural hit because it allows a baby to tune into his favorite thing to look at, his parent's face. Before they have object permanence, that favorite face disappears and reappears instantly. To help babies develop object permanence, parents can also play peekaboo by hiding behind a small towel. By holding the towel in front of their face and calling to the baby, as soon as the baby touches the towel, parent can drop the towel immediately and say, "You found me." Another option might be for the parent to put the towel on their head and allow the baby to pull it off, or putting the towel on their head and letting the baby find you by pulling it off themselves. In this way, the child starts to develop that sense of permanency, that things don't disappear just because they're out of sight. The object continues to exist, even though the child cannot immediately see it. By 9 to 12 months old, babies will be able to respond to verbal requests. This also signals that they understand communication and how to participate in communication. As babies get older, cognitive milestones become more complex. By the time they are 1, they're able to take things in and out of a container, and they were working their way into sorting items by shapes and colors. Between 3 and 5 years old, children will begin more complex tasks, such as learning to count, naming colors, knowing their name and age, making small decisions, understanding basic time concepts and sequencing, and enjoying play. By 6 to 11 years old, things become more logical and organized. They understand the timeline of past, present, and future, and can plan and work towards goals. They were beginning to understand cause and effect relationships and basic math skills. When we discussed the psychology of learning, we discussed Piaget's contribution to constructivist theory. Piaget's work in developmental psychology is so influential to the field of psychology as a whole that Jean Piaget was named the second most influential psychologist of the 20th century. He was second only to B.F. Skinner and was considered to be more influential than Sigmund Freud. Piaget's goal was to understand how the adult mind, particularly its capacity for objective reasoning, develops from the child's more primitive abilities. From his work, Piaget developed an elaborate, comprehensive theory of cognitive development. Piaget's fundamental idea was that mental development derives from the child's own actions on their physical environment. According to Piaget, children are constantly in their play and exploration, striving to figure out what they can do with the various objects that exist in their world. By acting on objects, children develop mental representations called schemas or schemata, which are mental blueprints for actions. More specifically, Piaget used the term schemas to refer to the mental representation of a bodily movement or of something that a person can do with an object or category of an object. Schemas develop through assimilation and accommodation. Piaget conceived of the growth of schemas as involving two complementary processes, assimilation and accommodation. Assimilation is the process by which new experiences are incorporated into existing schemas. However, few new stimuli perfectly fit an existing schema. Assimilation usually requires that existing schemas expand or change somewhat to accommodate the new object or event. Appropriately, Piaget referred to this process as accommodation. Piaget's theory of cognitive development suggested that intelligence changes as children grow. A child's cognitive development is not just about acquiring knowledge. The child has to develop or construct a mental model of the world. Piaget believed that cognitive development occurred through the interaction of nature, meaning inherent capacities, and nurture, environmental events, as children passed through a series of 4 stages. The sequence of these stages is universal across cultures and follow the same unchanging order. all children go through the same stages in the same order, but not all of them go through the order at the same rate. The 4 stages of Piaget's theory of cognitive development are the sensory motor stage, which takes place from birth to approximately 2 years old, the pre-operational stage, which occurs between 2 and 7 years of age, the concrete operational stage, which occurs somewhere between 7 to 11 years of age, and the formal operational stage, which occurs from age 12 moving forward. As a reminder, these are very rough cuts in terms of ages of when humans can be expected to go in and out of these stages. The first stage is the sensory motor stage and will generally take place between the ages of 0 and 2 years old. During this time, a child experiences the world through senses and actions. As far as developmental milestones, we already discussed the main developmental milestone of that stage when we discussed object permanence a few minutes earlier. The attainment of object permanence generally signals the transition to the next stage of development, which is called the pre-operational stage. The pre-operational stage is the second stage in Piaget's theory of cognitive development. This stage begins around age 2 and lasts until the child is approximately 7 years old. During this period, children are thinking at a symbolic level, but are not yet using cognitive operations. In other words, the child cannot use logic or transform, combine, or separate ideas. The child's development consists of building experiences about the world through adaptation and working towards the concrete stage, which is the next stage. There are key features of the pre-operational stage. One is the idea of centration. Centration is the tendency to focus on only one aspect of a situation at a time. Another is the idea of egocentrism. Egocentrism refers to the child's inability to see a situation from another person's point of view. The egocentric child assumes that other people see and hear and feel exactly the same way as the child does. A behavior that is associated with egocentrism is a child engaging in parallel play. Parallel play is when children play in the same room as other children, but instead of playing with those other children, they're actually playing just next to them. They're playing near them. Every child might be absorbed in its own private world, and the speech is egocentric. The main function of the speech at this stage might be for a child to externalize their own thinking rather than to communicate with the other children in the room. Another idea might be animism. This is the belief that inanimate objects, such as toys and teddy bears, have human feelings and intentions. By animism, Piaget meant that for the pre-operational child, the world of nature is alive, conscious, and has a purpose. Another important characteristic of the pre-operational stage is irreversibility. This is a child's inability to reverse the direction of a sequence of events to their starting point. In terms of translating some of these ideas to the classroom, irreversibility is really important to keep in mind when teachers are teaching young students new topics or new skills. It's very difficult for a student to be able to dismiss what they were previously taught. So when we're working with teachers, especially elementary school math teachers, it's very important that the teacher be very, very careful with the way they are presenting information to a child in the pre-operational stage. They don't have the ability to scrap what the teacher said a few minutes ago and redo things a different way. It makes it really, really hard for them, and it's working against their normal cognitive developmental processes. One of the experiments that Piaget created to look at egocentric behavior in children was the 3 mountains task. And Jean Piaget used the 3 mountains task to test whether children were egocentric. Remember, egocentric children assume that other people see exactly what they do. The 3 mountain test consists of a child sitting at a table, and in front of them are 3 mountains. The mountains were different. one with snow on top of one, a hut on another, and a red cross on top of another. The child was allowed to walk around the model to look at it and sit down at one side. Then the doll is placed at various positions on the table. A child is then shown 10 photographs of the mountain taken from different positions. They are asked to indicate which showed the doll's view. Piaget assumed that if the child correctly picked out the card showing the doll's view, that they were not egocentric. Egocentrism would be shown by the child who picked out a card showing what they saw from where they were sitting. 4-year-olds almost always choose a picture that represent what they could see and showed no awareness that the doll's view would be different from theirs. 6-year-olds frequently chose a picture different from their own view, but rarely chose the correct picture for the doll's point of view. Only 7 and 8-year-olds consistently chose the correct picture.
The concrete operational stage is a third stage in Piaget's theory of cognitive development. This period lasts around 7 to 11 years of age and is characterized by the development of organized and rational thinking. Piaget considered the concrete stage a major turning point in the child's cognitive development because it marks the beginning of logical or operational thought. The child is now mature enough to use logical thought or rules, but can only apply logic to physical objects. This is why it is called concrete operational. They have to have concrete items around them in order to apply logic. Children gain abilities of conservation in terms of number, area, volume, and orientation. They also gain reversibility, seriation, transitivity, and class inclusion. However, although children can solve problems in a logical fashion, they are not typically able to think abstractly or hypothetically. Let's look at the idea of conservation in developmental psychology. Conservation refers to a logical thinking ability that allows a person to determine that a certain quantity will remain the same despite any adjustments of the container, shape, size, or distribution. According to Piaget's theory, this ability is not present in children during the pre-operational stage, between the ages of 2 and 7. Rather, it develops in the concrete operational stage, from ages 7 to approximately 11 years old. Piaget developed different tests for various types of conservation. For each one of these experiments, he asked the children questions at the initial presentation of the objects and after the objects had been transformed. For example, when he was testing if the children were able to conserve volume, he presented the children with 2 equal glasses of liquid. So as you see here, these 2 glasses both have the same amount of liquid. He would then pour the water from one of the glasses into a tall, narrow glass and ask the children which one of the glasses had more water. He did a similar test by lining up 2 equal lines of checkers. So here they have 2 equal rows of 6 checkers. They are lined up perfectly so that the top row lines up perfectly with the bottom row, and ask the children whether the top row or the bottom row had more. Then he would space the checkers out unevenly. So while there's still 6 checkers in the top row and 6 checkers at the bottom row, the top row is further dispersed. And then he would ask the children which one has more, the top row or the second row. Children that had not developed their ability of conservation would be under the impression that the top row that was spread out contained more than the bottom row that was not spread out. Piaget also conducted similar experiments with clay by showing 2 equal balls of clay and then squeezing one out into a long, thin shape and asking the children which one had more. And he would test conservation of length by lining up 2 rulers or 2 sticks, one under the other, and then moving one to the side and then asking the same questions, which one had more or which one was longer. For the length test, children that had not yet developed conservation would be under the impression
that one of the rulers was longer because it had been moved past the other one. The fourth and final stage in Piaget's theory of cognitive development is the formal operational stage, which begins at approximately age 12 and lasts into adulthood. As adolescents enter this stage, they gain the ability to think in an abstract manner by manipulating ideas in their head without any dependence on concrete manipulation. For example, a person can do mathematical calculations, think creatively, and use abstract reasoning to solve problems. They can also imagine hypothetical outcomes to scenarios. An example of the distinction between concrete and formal operational stages is the answer to the question, if Kelly is taller than Allison and Allison is taller than Pamela, who is the tallest? This is an example of inferential reasoning, which is the ability to think about things which the child has not actually experienced and to draw conclusions from this thinking. A child who still needs to draw a picture or use objects is still in the concrete operational stage, whereas children who can reason and answer in their heads are using formal operational thinking. Other hallmarks of the concrete operational stage are children's ability to classify objects, put them together on the basis of color, shape, and also create subcategories. Children are also able to mentally arrange items along a quantifiable dimension, such as height or weight. The ability to mentally arrange items according to quantifiable characteristic is called seriation. Piaget's ideas on the formal operational stage have received quite a bit of criticism. Although Piaget proposed that all children, without exception, go through 4 different types of cognitive development, recent literature has demonstrated that not all adolescents will approach the formal operational stage. In some societies, the educational process does not focus on critical thinking, which is very essential to reach a formal operational stage. Studies show that only half of individuals in some societies reach the formal operational stage due to the lack of educational background. Moreover, sometimes individuals can illustrate formal operational skill in just one field. For example, an individual who is a very good engineer can think logically about this particular area, but at the same time are very likely to have difficulty thinking logically about something like poetry. Commonly held belief is that more complex thinking abilities will definitely emerge during adolescence. Some researchers suggest this is due to the increases in processing speed and efficiency rather than a result of increase in mental capacity. In other words, it's due to the improvements in existing skills rather than the development of new ones. One thing I did want to note is whereas children can be egocentric, adolescents begin to develop cognitive empathy, which is also known as theory of mind. It relates to the ability to take the perspective of others and feel concern for others. Cognitive empathy begins to increase in adolescence, and it is an important component of social problem solving and conflict avoidance. Cognitive empathy begins rising in girls at about 13 years old and around 15 years old in boys. Although Piaget's theories are highly respected, they are still challenged. In fact, while Piaget thought that children's ability to understand objects develops slowly as a child matures and interacts with their environment, some developmental psychologists today believe that Piaget was incorrect. More current research suggests that very young children understand objects and how they work long before they have experience with those specific objects. In a 1987 study by Bilargen, infants as young as 3.5 months old observed a truck rolling down a track. In the first part of the experiment, they noticed the truck going down the ramp and continuing forward. In the second part of the experiment, they noticed the truck roll down the ramp and move forward, but there was a box to the side of the ramp. In the third part of the experiment, the experimenters had the truck roll down the ramp and pass through the box. So the box was hollow, but the baby couldn't tell that the box was hollow. So it seemed as though the truck was going through the box. Infants spent more time looking at the third situation. According to the researchers, this may suggest that they understood that solid objects cannot pass through each other. So because this scenario was impossible, it confused the babies and it caused them to stare at it in the hopes of being able to make sense or learn from the situation. Using this experiment as support, Piaget argued that Piaget's findings regarding infants' failure to understand object permanence until 8 to 12 months old was more rooted in children's lack of motor ability as opposed to inadequate cognitive development. So saying that they couldn't find stuff was more due because of their actual body not being able to move and pick things up and search for things versus what they were thinking. In an effort to account for the infant's lack of motor skills, Piaget's studies of object permanence measured infants' fixation times, how long they spent looking at impossible versus possible events. Infants spent longer time looking at events that defied physical laws when hiding objects. This implied that infants do understand object permanence at an age as early as 3.5 months old. After adolescence, cognitive abilities remain steady through early and middle adulthood. Some cognitive abilities, such as vocabulary, are resilient to brain aging and may even improve with age, while other abilities, such as conceptual reasoning, memory, and processing speed, decline gradually over time. Concepts of crystallized and fluid intelligence are used to describe patterns of cognitive change over the lifespan. Crystallized intelligence refers to skills, ability, and knowledge that is overlearned, well-practiced, and familiar. Vocabulary and general knowledge are examples of crystallized abilities. Crystallized abilities remain stable and gradually improve every year through the 6th or 7th decade of life. Because crystallized intelligence is due to accumulation of information based on one's life experiences, older adults tend to perform better at tasks requiring this type of intelligence when compared to younger adults. In contrast, fluid intelligence refers to the abilities involving problem solving and reasoning about things that are less familiar and are independent of what one has learned. Fluid cognition includes a person's innate ability to process and learn new information, solve problems, and intend to and manipulate one's environment. Executive functioning, processing speed, memory, and psychomotor abilities are considered fluid cognitive domains. Many fluid cognitive abilities, especially psychomotor ability and processing speed, peak during your 30s and then decline slowly every year. It's important to understand how cognition changes into adulthood and into the final decades of life. Normal age-related cognitive decline may put individuals at risk for losing their ability to live independently. Everyday tasks, such as financial management or medication adherence, have substantial cognitive components. Inability to perform these tasks correctly may result in a person having to move to a family member's home, contracting a living caregiver, or joining a retirement community. Developing techniques or interventions that either enhance cognition or limit decline is of huge social importance, and there is much work to be done in this area. This was the second part of a 3-part video series on developmental psychology, with an emphasis of the role of cognition in developmental psychology. In part 2, we learned lifespan development explores how humans change, grow, and remain the same from conception to death. Human development can be studied scientifically across 3 domains: physical development, cognitive development, and psychosocial development. Different theories focus on processes, patterns, generalizability, biological influences, and environmental influences on human development. For reflection, please take a few moments to consider the following open-ended question. How can the theories of cognitive development help educators create meaningful experiences for learners of all ages? I'd love to get your thoughts in the comments below. That's it for this lecture. In the next lecture, we will continue to discuss developmental psychology, more specifically, psychosocial development. Before you go, don't forget to like this video and subscribe to Stats with Taurus for more Psych 101. Looking forward to it. Ciao!